Hi student friends, once again welcome to our online lecture of B.Sc.II. Analytical Chemistry. Yesterday you have learned about the functional group analysis first, in which we are estimate different functional groups. Today we are going to estimate today we are going to learn how to estimate the nitro group and another one, that is what ester group present in organic compound. So let's begin with the estimation. So student friends, here what the principle behind the estimation of ester group in the organic compound by hydrolysis method. So an accurately weighed organic compound containing ester group, that is what RCOR group is taken, that is W gram, and hydrolyzed by means of reflection with a known volume of standard alkali sodium hydroxide NaOH in excess when the following hydrolysis reaction occurs. When we reflux the W gram of the given ester group with the standard alkali sodium hydroxide, we will get the reaction, that is what the ester RCOR group, that is RCOR dash plus NaOH. This OH combines with R dash and will get the ROH alcohol plus, that is sodium salt of the fatty acid, that is sodium salt of the acid RCONA. So sodium salt of acid. Then what happened? The excess standard sodium hydroxide NaOH left unreacted is black titrated with the standard solution of hydrochloric acid HCl using either methyl or phenolphthalein indicator. The volume of standard hydrochloric acid consumed is noted and is treated as a main burette reading AML. What happens when this neutralization reaction occurs? This after addition of the reflection of this NaOH with the ester group, some ester group is reacted with alkali NaOH and some unreacted sodium hydroxide is left, and this left unreacted sodium hydroxide is back titrated with the standard solution of hydrochloric acid. Whatever the amount of hydrochloric acid consumed during this reaction is noted as a burette reading and the sample reading as a AML. What is the reaction happens? That is what the NaOH excess left unreacted treated with HCl will get the NaCl salt plus water, that is nothing but neutralization reaction, and what burette reading will get is the AML. In the second type of titration, that is blank titration, here what same amount of the volume of NaOH is taken for the titration, and the entire NaOH is taken for the blank is also titrated with a standard solution of hydrochloric acid using methyl orange or the phenolphthalein as an indicator. The volume of standard hydrochloric acid consumed is noted and is treated as a blank burette reading, that is what is small b. What is the reaction? NaOH reacts with HCl, gives what? Sodium chloride salt and water. So what happened? The whatever the amount of NaOH taken, that is standard alkali solution taken, that amount of the hydrochloric acid is consumed by means of that alkali solution. Suppose 10 ml of the solution is taken, 10 ml of the solution of that what the NaOH taken, then we will require to neutralize the reaction, that is what the HCl. So we will require 10 ml of HCl. Means what? The reading for this blank titration, that is B is equal to 10 ml. This is what the 10 ml reading. And if you consider what the sample titration, in sample titration we have what the reflux the given compound, that is what the reflux the given ester group, and whatever the ester group is refluxed with the NaOH, the reaction occurs, that is saponification reaction occurs, that is hydrolysis, that is base hydrolysis is occurred, and after base hydrolysis the some amount of sodium hydroxide is what left unreacted. When this suppose this is what 10 ml, so we have taken 10 ml of sodium hydroxide for the reaction, and 5 ml get consumed, 5 ml get consumed with the what the that ester group RC double bond O OR group, OR dash group. Then this 5 ml unreacted, left unreacted is what titrated with the left unreacted is titrated with the what the HCl. Then for the neutralization of 5 ml unreacted solution of sodium hydroxide, we require the 5 ml of NaOH, 5 ml of NaOH, then that is sodium hydroxide. Then this reading, that is nothing but A reading is equal to what? It is 5 ml. A is equal to 5 ml. So by making the calculation from what, subtracting the reading from blank and sample, will get the amount of that ester group present in a given what the organic compound. Means what, the whatever the amount, that is blank minus sample reading is there, this is directly proportional to the amount of NaOH consumed by ester group, and which is directly proportional to the amount of ester group. So what, the difference in the volume of the HCl consumed for the blank experiment A ml and for the blank ml and main experiment, that is B ml, is directly proportional to the amount of NaOH actually consumed by the ester during hydrolysis, which is proportional to the amount of ester present in the organic compound. So what happened, the blank minus main reading. So here what the B is the blank reading, here what the, this is B, not the E. So B minus A is the what difference between blank and sample titration, that is main, blank and main reading, and whatever the difference between these two, suppose it may be, suppose it is what, the 5 ml, then 5 ml NaOH required means what, 5 ml of that what, it is stoichiometrically whatever the 5 ml volume required is what, directly proportional to the amount of that ester group present in the given organic compound. So the difference in the volume of the HCl consumed for blank experiment B ml, it is not A, it is B ml, and the main experiment that is, this is A ml, is directly proportional to the amount of NaOH actually consumed by ester during the hydrolysis, which is proportional to the amount of ester present in the organic compound. So whatever the amount, it is directly proportional to the amount of NaOH consumed by ester, and which is further what, directly proportional to the butyrated, that is difference between the butyrated, that is what the blank and sample reading, that is blank and main titration reading. So this is about the how will you what estimate the ester group present in the organic compound. The next one is the formula for the calculation, that is percentage of ester group in the given organic compound. Hence, from the difference in the volume of HCl consumed in the blank and main experiments B minus A, the amount and percentage of the ester in the organic compound is calculated. Simply what the formula, percentage of the ester in organic compound is equal to B minus A, that is nothing but difference between butyrate reading, that is blank, and sample, or that is main titration, into normality of NaOH into m, that is molecular weight, into 100 divided by weight of organic compound into what, the 1000. This is what the simple formula for the what determining the amount of ester, percentage of ester group present in the given organic compound, where M is the molecular weight of the ester, and examples of organic compound containing ester group is methyl formate, that is HCOCH3, ethyl formate, that is HCOC2H5, methyl acetate CH3COCH3, ethyl acetate CH3COC2H5, ethyl propanoate C2H5 COC2H5. That is what the ester group present in this ester, that is different types of the ester. Then next one is the what estimation of nitro group in the organic compound by a redox method. Redox means reduction as well as the oxidation occurs in the reaction. So what is the main titration? An accurately weighed W gram of organic compound containing nitro group is boiled with a known volume of standard titration that is what the standard titanium sulfate solution in excess in the presence of current of inert gas, that is H2 or N2 or CO2. When the nitro group NO2 group is reduced to corresponding amine, that is NH2 group, as follows. See, RNO2 reacts with titanium sulfate, that is what 6 Ti plus 3 in oxidation state plus 6H, that is get converted into amine in acidic medium, that is what into what get this nitro group is get reduced and titanium get oxidized plus 4 state, that is what RNH2 plus 6 Ti plus 4 plus 2H2. This is what the overall oxidation and reduction reaction. Reduction of that RNO2 group takes place in presence of titanium sulfate, that is titanous sulfate, and the oxidation of titanium takes place. So we'll get the RNO2 is get converted into RNH2 and so on. So what is the simple reaction is that the except titanium, that is Ti plus 3 solution left unreacted, is then back titrated with the standard solution of ferric ammonium sulfate using ammonium thiocyanate as an indicator. The volume of ferric ammonium sulfate consumed for the main titration A is, that is titanium plus 3 plus Fe plus 3 gives what the oxidation of this titanium takes place and reduction of Fe plus 2. So ferric ammonium sulfate is an indicator. Titanium solution back titrated with the solution of ferric ammonium sulfate using what ammonium thiocyanate. Ammonium thiocyanate is the indicator. Then this ferric ammonium sulfate solution get what reduced to Fe plus 2 ion, and Ti plus 3 ion is get oxidized to Ti plus 4. So what is the back this is about the sample titration, main titration. Then after this the blank titration is similarly carried out. The same volume of titanium sulfate solution as that of main is taken without organic compound, that RNO2 is titrated with standard solution of ferric ammonium sulfate using ammonium thiocyanate as an indicator. Similar procedure is there. The volume of ferric sulfate consumed in the blank titration is what the B is noted. This B is nothing but the amount of ferric ammonium ferric ammonium sulfate required to what neutralize this titanium sulfate solution. The overall reaction is a redox reaction. Titanium gets oxidized and Fe plus 3 get reduced by means of using ammonium thiocyanate as an indicator. So whatever the reaction that is what the reading burette reading, that is from the main titration and from the blank titration, we can able to what calculate the amount of nitro group, percentage of nitro group present in the given compound. Simply what I once again repeat that the how to estimate the nitro group in organic compound by redox method. Main titration is there what an accurately weighed amount of organic compound is taken W gram, and then it is get what boiled with the known volume of standard titanium sulfate solution in excess. Then in the presence of a current of inert gas, that is H2, N2 and CO2, when the nitro group, NO2 group is what get reduced to amine group, that is NH2 group, then this RNO2 is get converted into RNH2, and this titanium is get oxidized plus from titanium plus 3 to titanium plus 4 in acidic medium. Then after that we will get the sample reading, main titration reading, and after that the excess after boiling, this solution is what titrated with the the excess titanium sulfate solution is what left unreacted is then back titrated with the standard solution of ferric ammonium sulfate using ammonium thiocyanate as an indicator. Then after what the getting redox titration reading, that is what the main reading, it is nothing but A, and this reaction is titanium plus 3 plus Fe plus 3. Then this titanium plus 3 is get converted into or oxidized into titanium plus 4, and this iron is reduced into Fe plus 2 from Fe plus 3. So this is about the what sample titration. Then blank titration, similarly carry out the blank titration, takes same amount of the titanium sulfate solution, and then titrate it against the ferric ammonium sulfate solution in presence of ammonium thiocyanate as an indicator, and treat this butyrate reading as a B, that is blank reading, and from this difference from the blank and sample we will get the amount of the that nitro group present in the given compound by redox method. So the difference in the volume of ferric ammonium sulfate consumed for blank titration and the main titration is directly proportional to the actual amount of titanium consumed by RNO2, which in turns is proportional to the what NO2 group in organic compound. So what is B minus A, that is what blank minus main butyrate reading, which is directly proportional to the amount of actual Ti plus 3 consumed for NO2 RNO2 group, and which is directly proportional to the amount of RNO2 group present in a given organic compound. Hence, from the difference in the volumes of the ferric ammonium sulfate consumed for blank titration, that is blank Br, and the main titration, that is main Br A, the percentage of NO2 group in the organic compound, that RNO2, is calculated by means of the formula. The percentage of nitro group in RNO2, that is equal to B minus A, that is difference between the blank titration and the main titration, into normality of titanium sulfate solution into 46, that is the conversion factor, into what the conversion factor, or it is what the molecular weight of NO2, 16 plus 16 and 14. So 46 into 100 divided by weight of organic compound, W into 1000. So in this way, with the help of this formula, we can calculate the amount, that is percentage of the given nitro group present in given organic compound. The examples of organic compounds containing nitro groups are nitrobenzene, that is C6H5NO2. This is nothing but nitrobenzene. We can also able to draw the structure of nitrobenzene. So what happened, this nitrobenzene is there. So this is what nitrobenzene, and another one nitroaniline is there, that is it is what para, meta and ortho nitroaniline is there. Next one is the nitrophenol is there. So all these are the organic compound containing nitro groups. So we are able to determine or estimate the amount of nitro group present in the given organic compound by means of the redox method, as well as we are able to determine or estimate the amount of ester group present in the given compound by hydrolysis method. So if you have any queries regarding this topic, please put question in the YouTube comment box. I will try to answer all these queries. Thank you. Thanks a lot. Have a nice day. Thank you.